Alright, we're taking a look at some of the trickier ones from our similar angles homework. So let's dive in. Our first one was number 9, and this was the one with the guy wires attached to the telephone pole. So this is a tricky one where it's like deciding what we know and what we don't know is a big part of the tricky problem here. So we've got, of course, two similar triangles, right? We've got first this smaller triangle here, and then we've got this bigger triangle here. And I know that these triangles are similar because I know their angles are the same, right? They both have a 90-degree angle, they both have a 75-degree angle, and of course there's only 180 degrees in each triangle, so that means that the remaining angles must also be equal. So I know they must be similar triangles, and we can treat them as similar triangles. So let's see what we know about them. Our triangle on the left here has one side that's 3, and then it's got a side we don't know, so we're just going to call that X. That's the side that's like next to the pole here. And we know above that there's 7.46 meters that takes us to the top of the pole. Well, since the other wire attaches to the top of the pole, that means that this side right here on this bigger triangle is going to be that X of the other triangle plus 7.46 meters. So when we set up our similarity statement, let's write the small triangle first. I'm going to say 3 to x, comparing the two sides of the smaller triangle. Now let's compare that to the two sides of the bigger triangle. It's going to be 5 to x plus 7.46. So now we've set up our similarity statement, and we only have one unknown. It's x. It does appear in two places, but we can still figure it out from here. Let's do our little cross multiply game. X times 5 is 5x. And then 3 times x plus 7.46 is 3 times x plus 7.46. Let's take that 3 and multiply it through the brackets. And we're going to end up with 5x equals 3x plus, now actually, what is 3 times 7.46? I'm going to throw that into a calculator. 7.46 is 22.38. So 22.38. Good. Let's subtract 3x from both sides. So we have all of our x terms on one side. 5x minus 3x is 2x equals 22.38. Let's divide both sides by 2. And what we're going to end up with is 11.19. 11.19. Now, does that answer our question? It says determine the height of the pole. It doesn't. That only tells us x. So what we have to do is add the 7.46 to the value of x, 11.19. So let's do that. We'll say h for height of the pole is 11.19 plus 7.46. So the height of the pole is going to work out to 18.65 meters. And then we do a little therefore statement. Therefore, the pole is 18.65 meters. Okay, let's move on to our next one. Okay, here's our next one. This one's a pretty tricky one. So we've got this like laser sight thing set up to be able to figure out how high the hill is. Really what we've got going on here is 3 different triangles. So I'm going to draw my smallest triangle first. It's going to look like this. It's got a height of 1, and I'm going to call the distance between one of the vertices in the triangle and this first laser sight, I'm just going to call that x because it's a distance I don't know. Then I've got a slightly bigger triangle, and this is the one that has the bar that's 1.6 meters high. So this distance here is going to be x plus 12. It's that extra 12 meters plus the x. And then I've got a really big triangle, like this. And we know that it's got a height of h. That's something we don't know. And this distance on the bottom is going to be x plus 12. That's this distance here, plus another 415. So really, I could cross that out, right? And I could say that's going to be x plus 427 when we add the 12 and the 415. Okay? So that's my 3 similar triangles. Now I don't want to mix together in a proportion the unknown h and the unknown x because then that'll be too many unknowns I won't be able to solve. So I got to do one at a time. So let's use my first two triangles and use them to solve for x. So I'm going to say my first triangle 1 over x is going to be equal to, let's compare my second triangle, 1.6 over x plus 12. Okay, if I want to solve, I'm going to end up with 1.6x equals 1 times x plus 12 is just x plus 12. Let's get a little more room here. Subtract 1x from both sides. That's going to leave me with 0.6x equals 12. Divide both sides by 0.6. End up with x equals 20. So that distance there is 20. So now I actually know this whole distance, right? It's 20 plus 427. So that's going to be a total of 447. That's how long that side is. And now I can compare my first triangle to my last triangle, my smallest one to my biggest one. Let's do that. So we're going to say 1 over, we know x is 20, so 1 over 20 is going to compare to h, our unknown, over 447. So let's solve that. Cross multiply, 20 times h equals 1 times 447, so that's just 447. Divide 447 by 20, and we're going to end up with 22.35 meters. And then we can do, therefore, the hill is 22.35 meters tall. Tricky one. Okay, let's go on to our last one. Okay, for my last one here, I've got this set up with these mirrors, and the nice thing is I know that those two angles are equal to one another. So I know my angle of incidence and my angle of reflection, those are equal. And I also know that they each have a 90-degree angle, and that means the last angle is also equal because you can only have 180 degrees in a triangle. So those are similar triangles. Now the triangle on the left, I know two of the sides. My triangle on the right, I know one of the two sides. Let's call this unknown h here. Let's set up our ratios. My small triangle, if I go, the base is 0.5 and the height is 1.6. And my bigger triangle, the base is 5 and the height is h. It's our unknown. Let's do our cross multiply. So 0.5 times h equals 5 times 1.6. So that's 8. And then I'm going to divide both sides by 0.5. That's going to be the same as doubling, so this is going to be 16. Now you might have looked at this and said, oh, 0.5 goes to 5, that's 10 times bigger, so 1.6 goes to 16, that's 10 times bigger. That would be a fine way to do it too. So we say therefore the window is 16 meters tall. Okay, so those are some of the trickier questions from similar triangles. I hope this has helped.